Are you wondering where things went wrong? From the previous formative quiz on vector addition that was uploaded together with the YouTube playlist on vector addition, you might be wondering in which items you got it wrong and in what items did you have or did you encounter some misunderstanding or confusion. So hopefully this video will enlighten you and will help you correct these mistakes when we go to our next assessments. First question, what are the two ways presented in adding vectors? So we have the following choices: parallelogram method and triangle method, protractor and ruler method, and then lastly, we have graphical method and analytical method. There was an option in the formative quiz of none of the above, but obviously that will not be the answer. So the correct answer here is graphical method and analytical method. Some students came across parallelogram method and triangle method, but these two are still under graphical method. And we did not discuss them in depth because we are thinking that in due time, we're going to focus, of course, in the analytical method. We only presented you with the graphical method so that you can experience this kind of adding vectors. Next, in adding vectors graphically, how do we illustrate the next vector? So it is important that you know how we do the graphical addition of vectors. The correct answer is head to tail. Meaning to say, from if you watch the YouTube playlist video on one-dimensional and then two-dimensional graphical addition of vectors, you can see there that after graphing the first vector, it ends with an arrowhead, and then on that arrowhead starts the next vector. So it's important that you draw the very first vector correctly, otherwise the rest will be wrong if you graph the first vector incorrectly. Next, if the scaling of the vector is 1 kilometer is to 2.5 inches, how many inches should you illustrate if the resultant vector is 10 kilometers? So this is because we are trying to uh, fit the 1 kilometer measurement to or on paper. So that's why we are going to use a scale. So be wise in choosing, of course, the scale. So here, the scale is 1 kilometer is to 2.5 inches. So I will represent the 1 kilometer by 2.5 inches on paper. So with this, we ask ourselves how many 1 kilometer can we get from 10 kilometers, and the answer will be 10. So 10 times 2.5 inches, you'll get 25 inches. So therefore, your answer here should be 25 inches. Be very wise in choosing this scale so that when you graph it on paper, it will not be going out of the paper. Okay. Next, graphical method in terms of vector addition is prone to error because first person who is measuring the value may record it using an old protractor or ruler. Second choice, we have thickness of the pen or pencil affects the recorded value of the magnitude and direction. The next, we have graphical method is limited to how precise your illustration is, or all of the above. Well, it's all of the above. Graphical method is prone to error because of these things. If you use an old protractor or ruler, I mentioned what type of protractor is more preferable to use, the one with no hole, because the lines indicating the measurement of the angle is continuous, and so there will be less error in reading the angle measurement. If you use an old ruler, it may cause some problem in reading the measurement in case the calibrations cannot be seen clearly. Thickness of the pen or pencil. So if you're not very accustomed to doing the graphical addition yet, if you use a thicker writing tool like what I did in the video, the whiteboard marker, you need to move a little the ruler so that it appears to be accurate. The measurement appears to be more accurate. So I did some adjustments there so that there will be less errors. You'll get to that soon. Graphical method is limited to how precise your illustration is. Of course, if you did not uh, do a good job in exactly um, drawing the right measurements on paper, then the resultant vector will be incorrect. The measurement of that is will be totally different from the analytical method. Rest assured, a small or a slight discrepancy is acceptable, but if it's too far, like 10 units, both on the length and the angle measurement, then there really is something wrong. Next, which method of vector addition pertains to the use of geometry and trigonometry? Of course, this is analytical method. Which of the following quantities pertains to the resultant vector? This is the displacement. The resultant vector, therefore, is the blank. It is a displacement, and displacement is defined as the distance from the initial point to the final point. Given two vectors of the following measurements or the following magnitude and direction, what is the magnitude of the resultant vector? Since these two vectors form a right angle, one starts from the east and then one goes to the north. So you can observe that these vectors form a right angle. Then if we draw the resultant vector, we're going to form a right triangle. With this, you can use the Pythagorean theorem to solve for the magnitude of the resultant vector. So the answer here is 11.18 meters. In which quadrant can we locate the resultant vector? So since vector A is solely on the east, it means that this vector is on the x-axis, to be more specific, on the positive x-axis. Wala siyang y component, but it has a positive x component. Positive x. Well, vector B, this lies on the y-axis, to be more specific, on the positive y-axis. It doesn't have any x component, so 0 ang x component niya, but it has a y component that is positive, positive 11. So positive x and positive y, we get this on the first quadrant. So the answer here is the first quadrant. Next, given two vectors, okay, this is the same vector, what will be the direction with the bearing of the resultant vector? The correct answer here is north of east. If you compute, what will be the direction of the angle with bearing of the resultant vector? So you use the tangent inverse of the angle, tangent inverse of 11 over 2, and you get your 79.70 degrees north of east. Next, what will be the direction of the angle in standard position? So north of east is a bearing that implies an angle in standard position, so it's just the same value, so 79.70 degrees in standard position. Next, given two vectors with the following measurements, what is the standard position of vector A in degrees? So vector A, you have 14 degrees north of west. So it's on the second quadrant. Okay, north of west, it comes from the west going to the north. So to get the angle in standard position, we subtract 14 from 180, so we get 166. Again, the answer here is 166. Next, what is the standard position of vector B in degrees? We now have 30 degrees west of north. It comes from the north going to the west. Therefore, if we adjust it so that it starts from the positive x-axis, it will pass through the first quadrant, that's 90 degrees, plus 30, you get 120 degrees. So the angle in standard position of vector B is 120. Next, what is the summation of the x components in meters? So x components, we use 2 cosine of 166 plus 11 cosine of 120 degrees you get the answer of negative 7.44. Again, the summation of the x components is negative 7.44. What about the summation of the y components? So to solve for the y components, we add the y components of the respective vectors. So we have 2 sine of 166 degrees plus 11 sine of 120 degrees. If you would notice, the angles that we're using are those that we've already rewritten in standard position and not the given. Okay? So the answer for the y component, summation of the y component, we have 10.01. So previously, we have a negative x value, negative 7.44, and we have a positive y value, which is 10.01, meaning to say, in which quadrant does this resultant vector lie? Negative x, positive y is on the second quadrant. What is the magnitude of the resultant vector? So we've already solved for the x component, summation of x, and then summation of y. To solve for the magnitude, we add the squares of the summation of x and the summation of y, and then we get the square root of this sum. With this, we're going to get 12.47. 12.47 meters. Next, what is the angle in standard position of the resultant vector? Again, it's on the second quadrant. So it should be uh, greater than 90 but less than 180. So if we solve it, tangent inverse of 10.01 divided by negative 7.44, you will get a negative value. Okay, and then we use the vertical angle theorem to transfer it to the second quadrant. And then we solve for it for the angle in standard position. Your answer should be 126.62. If after watching this video, you still weren't able to get the correct answers, rewatch it, and then try to redo your solution, resolve it, until you arrive at the same answer. Okay, it takes practice. That's all. I'll end the video here.